Actually 96. Turn to page 96. I'm gonna talk, or we're gonna not do like exactly what they want. I mean, we're gonna do a little more than they want us to, but not 100% what they want us to, basically. We're just gonna look at each of these equations, and we are going to figure out some characteristics of these equations, I guess would be the best way for me to word it. So what we are going to do, guys, is we are going to be given these equations, and we're not going to use long division and rewrite them to find the asymptotes, but we are going to use we are going to find our vertical asymptote, our horizontal asymptote, our x-intercept, our y-intercept, our domain, and our range. We're going to find all that information out about each of these, okay? But before we do that, I'm going to get an equation out of the book here, and I'm going to write it at the top. Alright, so just so you see where I'm getting it, I'm going to use this equation right here just so that we can look at a few different things. So I'm going to write g of x is equal to 4x over x minus 3. Okay, so when we look at this equation here, there's a few different things that we can get. If we're looking for our vertical asymptote, our horizontal asymptote, we're looking for our x-intercept, y-intercept, domain, and range. So I'm going to circle each of these, and we're going to figure out where we can get what from. Alright, so we can get our range and horizontal asymptote from these two leading coefficients. That's going to be our range and our horizontal asymptote. Range and horizontal asymptote. Well, what's the leading coefficient in front of this x right here? In front of the x is a 1, right? Understood 1? So what's 4 divided by 1? 4. So for our horizontal asymptote, I would say y is equal to 4. Well, how does that tell me the range? Your range is always all real numbers except y cannot equal 4. Alright, next I've got my vertical asymptote and my domain. Vertical asymptote in our domain. We take our equation x minus 3 and set it equal to 0. So if I said x minus 3 equals 0, I would know x equals 3, right? So my vertical asymptote would be x equals 3. So that means my domain is all real numbers except x cannot equal 3. And that was our vertical asymptote and domain. All right, x-intercept. X-intercept is we just take our numerator and set it equal to 0. For our x-intercept, take your numerator and set it equal to 0. All right? So 4x equals 0, that means x equals what? 0. So my x-intercept is at x equals 0. And then last we've got our y-intercept. We take our two constants at the end. Is there a constant up here? So that's an understood 0, right? 0 divided by anything is always 0. So that was our y-intercept. All right, so we used that examples. I don't know why this won't focus.
I'm not sure I understand.
Ooh. See? We're going to use all that information to figure out what we need to for these, okay? So let's start with our vertical asymptote. We said that came from our bottom, okay? Vertical asymptote and domain. So I got 2x plus 1 equals 0. 2x equals negative 1, so that means x equals negative 1/2, right? So x equals negative 1/2. And what else does that tell us? That also tells us our domain, right? All real numbers, x cannot equal negative 1/2. All right, now let's look at our horizontal asymptote. That comes from your two leading coefficients. So in this case, it's 6 and 2, right? What's 6 divided by 2? 3. So that also tells me my range, y cannot equal 3. X-intercept comes from your numerator. So I could say 6x equals 0, so that means x equals 0, right? So my x-intercept is at x equals 0. And then last but not least is my y-intercept, and that comes from my last two constants, and that's 0 over a, what is that, a positive 1? 0 over positive 1 is just still 0. I do want us to practice labeling our asymptotes. Just to save us time, though, I'm not going to worry about plotting any points today. But I do want us to look at labeling our asymptotes. So my vertical asymptote, I'm going to do it in purple, and that's at negative 1/2. So that would be right in this area, right? You'll see what I'm doing there? My horizontal asymptote is at y is equal to 3, so 1, 2, 3. Is everybody caught up on A? All right, now let's do the same for B. I'm going to go ahead and write out, I've got vertical asymptote, horizontal asymptote, x-intercept, y-intercept, domain, and range. Okay. So we can start with our vertical asymptote. It comes from the bottom, remember. So I would say x minus 6 equals 0, so x equals 6. Domain, I'm going to say all real numbers except x cannot equal 6. Okay, next I've got my horizontal asymptote, which comes from your two leading coefficients. They're both an understood what? Huh? 1. So that's going to be y is equal to 1. So that means all real numbers except y cannot equal 1. Next, I'm going to look at my x-intercept that comes from the numerator. And we just say x equals what? X equals 0. And then last but not least is my y-intercept, which comes from your two constants. And mine's 0 over negative 6, and 0 over negative 6 simplifies to 0. So again, I'm just going to label my asymptotes just so that I can practice looking at those or seeing those. Vertical asymptote is at x equals 6, so 1, 2, 3, 4, 5, 6. So it's way over there. My horizontal asymptote is at y is equal to 1. All right, so this next part, they're not wanting us to graph anything. They just want us to find the asymptotes. So I'm going to show you, this is example 2, and they're just telling you how to find the vertical asymptotes, which I've told you how to do that. And then you see they give you, you can kind of see they give you 3 different cases, case 1, case 2, and case 3. So case 1 says the degree in the numerator is less than the degree in the denominator. Do you see that? You see how the degree in numerator is smaller than degree in denominator? What that means is you're going to have a horizontal asymptote at y is equal to 0. If the degree in the numerator is greater than the degree in the denominator, so do you see how numerator is bigger than denominator? Then that means there is no horizontal asymptote. If they are the same, which we have been dealing with them being the same, if they are the same, you take your two leading coefficients. No, that's horizontal. I was thinking vertical. No, that's right. You take your two leading coefficients and you divide by, and then you simplify them. Are you recording? Yeah. So, I'm going to write that. I'm going to summarize that over here for us. And I'm going to say if the degree of the numerator is less than the degree of the denominator, then your horizontal asymptote is y is equal to 0. Second case, if the degree of the denominator is greater than, or if the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. So if the degree of the numerator is greater than the denominator, then horizontal asymptote is none. And case number 3 is if the degree of the denominator is equal to the, or if the degree of the numerator and denominator are equal. So if the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is y is equal to leading coefficient over leading coefficient. I'll give you a second to write all that down. All right, so vertical asymptote. Nothing has changed with that. That still comes from your denominator. Okay? Well, you may be thinking, well, what can I really do with this? Guess what? We got to factor this bad boy. So take x squared minus 2x minus 8. That factors into x minus 4 times x plus 2. So what would x equal? X equals 4, right? And x equals, what else? Negative 2. So I would write x equals 4, x equals negative 2. So now we can fill out our domain. That's all real numbers, correct? Except x cannot equal negative 2 or 4. Obviously, we're not doing this habits. All right, for our horizontal asymptote, that comes from your two leading coefficients if our denominators were equal degree. Are they equal degree? They're the same, aren't they? So this would be 2 over 1, which is 2. So that would be y is equal to 2. So that would say all real numbers except y cannot equal 2. Because we'll come back, because these are going to give us very ugly x and y intercepts, and we don't really have enough room for those. So if we have time at the end, we might come back and work those, okay? But for now, let's just focus on our vertical asymptote, horizontal asymptote, domain, and range. All right, B. Vertical asymptote comes from our denominator, right? So I'm going to say 3x squared minus 12. And I'm going to set it equal to 0, so I can say 3x squared equals 12. X squared equals 4. We take the square root of both sides. So how many, what's my vertical asymptote? What's the square root of 4? Not just 2, but plus and minus 2. So my vertical asymptotes are x equals -2 and x equals +2. So that means my domain is all real numbers. X cannot equal -2 or 2. Horizontal asymptote we know comes from our leading coefficients since our degree is the same. What's my leading coefficient in my numerator? Understood what? 1 over 3. So y is equal to 1 over 3. My range is going to be all real numbers except y cannot equal 1 over 3. I think these are going to be a little bit prettier for us down here. So let's try our vertical asymptote, horizontal asymptote, x-intercept, y-intercept, domain, and range. Alright, same thing right here. We're going to take our vertical asymptote, x plus 8 equals 0, so x equals -8. That also tells me my domain. Alright, now I've got my horizontal asymptote. These are the same degree, so we're going to say it's 4 over 1. So that means y is equal to 4. Range is all real numbers except y cannot equal 4. X-intercept comes from the top here. So that'd be 4x minus 3 equals 0. 4x equals 3. X equals 3 over 4. And my y-intercept comes from my back two numbers. Trying to figure out why this isn't right. There we go. Which is -3 over 8. So y is equal to -3 over 8. I'm actually going to come way over here and draw my y-axis so that we can draw our asymptotes on here. Vertical asymptote is at x is equal to -8. So 1, 2, 3, 4, 5, 6, 7, 8. It's 1. My horizontal asymptote is at y is equal to 4. So 1, 2, 3, 4. So that's up here. Right? Next one. We got our vertical asymptote, horizontal asymptote, x-intercept, y-intercept, domain, and range. Alright, vertical asymptote comes from your denominator. So we say x minus 1 equals 0. So that means x equals 1. All real numbers except x cannot equal 1. Alright, next I've got a horizontal asymptote that comes from your first two, or your leading coefficients if these are the same degree, which they are. 3 over 1 is y is equal to 3. So all real numbers except y cannot equal 3. And then your x and y intercepts. X-intercept comes from your numerator. 3x plus 2 equals 0. So 3x equals negative 2, or x equals negative 2/3. Y-intercept comes from your two constants. That's 2 divided by negative 1, which is a negative 2. My vertical asymptote, my horizontal. Alright, everybody got all that information? Got 2 more problems and we'll be finished. Alright, this one says new techniques have changed the cost of the function, and that's piggybacking off of example 4, which they talk about the cost of removing a pollutant and how much money it's going to cost to remove it. So this says new techniques have changed for the cost of the function. For the new function, they give you this new equation. What percent of the pollutant can be removed for $50 million? So this is saying that if I've got G of P is equal to 3.2P plus 1 over 100 minus P, and they're telling me that G of P is equal to $50 million, or they're trying to figure out how many, or how much percent of the pollutant could we get rid of for $50 million, basically. So what I'm going to do is I'm going to replace 50 with G of P, and I say 3.2P plus 1 over 100 minus P. And from there, I can cross multiply, right? I'm cross multiplying. So I've got 50 times 100 minus P is equal to 3.2P plus 1. So 5,000 minus 50P is equal to 3.2P plus 1. Negative 50P is equal to 3.2P minus 4,999. Subtract 3.2P to get negative 53.2P is equal to negative 4,999. So that means P equals approximately 93.96. If we were to round to the nearest whole number, That would be about 94% of the pollutant could be gone with $50 million of that city, or whatever it is. All right, one last problem here. Vertical asymptote, horizontal asymptote, x-intercept, y-intercept, domain, and range. We find our vertical asymptote from your two leading coefficients if, nope, I just said that all wrong. Good thing I can erase, right? We find our vertical asymptotes, not horizontal, from your denominator. So vertical asymptote, 2x squared minus 10 equals 0. So we could say 2x squared is equal to 10, divide by 2. X squared equals 5. So that means x equals plus or minus the square root of 5. So my vertical asymptotes are x equals negative square root 5, x equals positive square root 5. And the square root of 5 is 2.2. So x is approximately plus or minus 2.2. And I'm doing that so it's a little bit easier for us to graph in just a second, okay? Next, we've got our horizontal asymptote. That is what comes from your two leading coefficients. So that would be 1 divided by 2, which is just 1/2, right? My x-intercepts come from my numerator. X-intercepts come from my numerator. So if I've got x squared minus 5x plus 6, I'd have to factor that. That's x minus 3 times x minus 2. So we say x equals 3 and x equals 2. Those are my x-intercepts. Y-intercepts come from the constants at the end of my equations there. So that would be, so my y-intercept would be negative 6 over 10, which simplifies to negative 3 over 5. Yeah, didn't it? Huh. It's not over here though. Well, maybe it'll unfreeze on y'all's. It's not frozen on the computer over here, so I'll finish it up on the computer and then see what I can do for y'all. Alright, so my domain would be all real numbers except x cannot equal negative square root 5 or positive square root 5. Range is all real numbers except y cannot equal 1/2. So I'm just going to draw the asymptotes here. negative 2.2 positive 2.2 and then a horizontal asymptote at y is equal to 1/2.